Most people treat an EPDM pull test like a final answer, but on Chicago industrial roofs, it's more like a snapshot that can look fine on Tuesday and fall apart after the next hard swing in temperature and roof activity. You see pass on paper, then you're back out there with leak calls, stained ceiling tile, a tenant asking for downtime you don't have, and a Q2 budget that suddenly needs to cover work nobody planned. Everything here comes from what we are seeing right now across the corridors through Structural Solutions Chicago. Not a manufacturer's sheet, not a national average, and not a clean lab setup. If you manage facilities out here, you need corridor-specific patterns you can plan around, because that's what keeps your scope and your spend stable when the first heat spike or late freeze hits. So why do these failures cluster in the corridors even when the spec and install history look fine? Let's start with what everybody blames, then move to what's actually driving it. Most of the time, people blame age when an EPDM seam starts acting up. But the real stressor we keep seeing is the combination of huge thermal swings and freeze-thaw cycling that hits these wide-open roof fields hard. On some roofs, you can get a near 100-degree surface swing across a day. Then you stack a cold snap on top of that, and the membrane and the details move in ways a single test just can't capture. This starts small, and that's why it gets missed. The seam edge, the termination bar line, the inside corner at a curb, those spots pick up tiny splits you won't notice walking the roof. Then water finds its way in during the next rain and sits where you can't see it because the surface still looks fine. Once that moisture sits under the system, freeze-thaw does the real damage. Water expands when it freezes. It pushes. It breaks a little more of the bond line. Then it thaws and relaxes. And that cycle repeats until the seam that passed starts peeling in the same direction every time you probe it. You aren't looking at one bad day of workmanship. You're looking at a joint that's been worked over and over by movement plus trapped moisture. That's why EPDM gets flagged in field testing. EPDM relies on adhesive performance at seams, terminations, and flashings, and that performance changes with temperature, surface moisture, and the condition of what's underneath. So you can test a spot that's dry, warm, and stable and get a number you like. Then a week later, the same roof goes through a cold rain, a freeze, and a sunny rebound, and the seam behaves like a different system. TPO doesn't magically avoid this, but the failure mode often looks different. With TPO, you tend to see issues telegraphed through weld consistency, stress cracking at tight details, or problems where plates and fasteners concentrate movement. With EPDM, it's more often a slow loss of seam integrity at specific lines, and the first sign is that spongy feel nearby or a pull test that falls off fast once you get past the top surface. Chicago corridors add their own amplifiers. Wind exposure across big, unobstructed buildings drives uplift at perimeters and corners. And if parapet and edge detailing doesn't match the actual conditions, those edges flex and tug at the nearest seams. Older decks and uneven insulation packs matter too, because when the substrate isn't flat and stable, the membrane moves more, and the seam sees that movement as shear right where you least want it. This is also why passes once doesn't mean holds through a season. A snapshot test tells you what that spot did in that moment, but your roof lives through repeated expansion and contraction, and it lives through water sitting longer than you think because of minor slope changes that don't show up from the street. If you're planning Q2 work, start by sampling the zones that take movement and water first. Perimeters, corners, transitions, and the seam runs that line up with recurring leaks. Then pair seam testing with moisture scanning so you know where the wet edge really is. When you read a report, push for clarity on temperature conditions during testing, where the samples came from, and whether the test points represent the roof's stress zones or just the easiest places to access. Go to structuralsolutionschicago.com, send your address and roof type, and ask for the Structural Solutions Chicago Roof Assessment. Get the data before Q2 forces your hand.